Okay, hello everybody. So in this play posit, what's going to happen is I'm going to scroll through these slides. There are 20 multiple choice questions. You'll put your answers into play posit. Play posit will let you know whether you got them right or wrong. And then after I scroll through all the problems, I'm going to rewind and then start doing the solutions so you can see if you got any wrong, what you did wrong, and all that good stuff. So here we go through the problems. Every problem comes in a pair of questions. The first question asks, which derivative rules should you use to take the derivative? And then the second question is asking you to actually find the derivative. So here we go. Okay, so now I'm going to rewind and start going through the answers. Okay, so if I were doing this problem, I would use the power rule. So this is the same thing as 6/21 x cubed get 6x squared over 7, which is answer choice C. All right. Next problem. All right, so here we are going to use the chain rule. So the 5 stays out in front. When we take the derivative, so here sine of x is the outside function, and x to the fourth plus 2x is the inside function. So when we take derivative of the outside, we get cosine x, because that's the derivative of sine. We leave the inside function alone. And then we multiply by the derivative of the inside function, 4x cubed plus 2, which is answer choice D. All right. Okay, so this is a log problem. The first question you want to ask yourself when you have a log problem is, can I use log properties to simplify this before I take the derivative? And the answer is yes, so I would rewrite this as natural log of x plus 1 minus natural log of x plus 5. That's just the quotient property for logs. So then I can take the derivative of each term. The derivative rule for natural log is derivative of the inside of the function over what was inside the function. So the derivative of x plus 1 is just 1 over x plus 1, and then minus 1 over x plus 5. But oh no, that's not any of the answer choices. So when I look at the answer choices, all of them are, most of them are combined into a single fraction. So I'm going to make a least common denominator. So the common denominator is x plus 1 times x plus 5. The first fraction was missing an x plus 5, so you have to multiply the numerator and denominator by x plus 5. Second fraction was missing an x plus 1, so you multiply the numerator and denominator by x plus 1. Then when you combine these, you get x plus 5 minus x minus 1 all over x plus 1 times x plus 5. And when you combine like terms, these x's cancel out, and you just get 4 over x plus 1 plus x plus 5. That's still not any of the answer choices, but if you FOIL the denominator, you get x squared plus 6x plus 5. Which isn't any of these answer choices, but it should be A. I made a boo-boo when I made this. Why can't I be perfect? All right, I'm going to have to fix that. All right. Oh, hello. My dog says hello. Okay, next problem. No, I don't want to save the changes. Okay, so to do this problem, we're going to have to use the product rule, because we have the product of two functions. And then when we take the derivative of the second term, we're going to have to use the chain rule, because the rule to take the derivative of an exponential function is the chain rule. All right, so product rule. Okay, derivative of the first term in the product is 2x times the second, e to the sine 4x. And then plus first term times the derivative of the second. So the derivative of an exponential is the original exponential, e to the sine of 4x, times the derivative of the exponent. So the derivative of sine is cosine 4x times the derivative of what's inside. So the derivative, so the second term of the product rule is x squared times e to the sine 4x times cosine 4x times 4. So I'm just going to try to clean up a little bit, hopefully where I have a little bit more space on the screen. So the first term was 2x times e sine to the 4x. And then second term plus at 4x squared e to the sine of 4x times cosine of 4x. Okay, so when I'm looking at this multiple choice question, even before I take the derivative, since I know I'm going to use the product rule, there's going to be a sum involved. So I'm going to eliminate any answer choices that don't have a sum in them. So before I even took the derivative, I could eliminate these two options. Those are wrong. So hopefully one of these is what I have written here. So 2x e to the sine 4x plus 4x squared. Oh, looks like we have a winner right here. All right. Okay, so this problem is on here to make sure that you know that you do not need to use the quotient rule just because you see a quotient. In this problem, I would rewrite this as 5x to the negative 3 first. Oh, great. Okay. And then you just simply do the power rule. Negative 15x. And the most common mistake here is that when people reduce the exponent by 1. Sometimes they'll put x to the negative 2, but the original exponent was negative 3. When you subtract 1 from negative 3, you get negative 4. But oh no, that's not any of the answer choices. However, if I rewrite this so that the exponent on x is positive, you get negative 15 over x to the fourth, which is answer choice D. Okay, so in this problem, again, it looks tempting to use the quotient rule, but we're not going to. We're actually going to use the chain rule instead because the quotient rule is the devil. So here we go. So the first thing I'm going to do is rewrite this. Y equals 2 times x over 2 plus 7 to the negative 12th. And now I'm going to use the chain rule. I've rewritten this so that there's no fraction bar. Okay, so when I do the chain rule, the x over 2 plus 7 is the inside function. The outside function is x to the negative 12th. When I take the derivative of the outside function, I'll get negative 12 and bring down the exponent times the 2 that was sitting out front to begin with. Leave the inside function alone. Reduce the exponent outside by 1. That's just the power rule. And then I need to multiply by the derivative of the inside function. The derivative of x over 2 plus 7 is just 1/2. And then you get some cancellations. This 1/2 and this 2 cancel. So you get negative 12 x over 2 plus 7 to the negative 13th. So again, that's not any of the answer choices, so I'm just going to rewrite this. I'm going to make the exponent on x over 2 plus 7 positive by moving it to the denominator. And I believe that is answer choice A. So hooray. Okay. Okay, this one looks fun. So here we are going to use the chain rule twice. We have a function and a function and a function. It's like a turducken of functions. So the outermost function is cosine, and then the second function is natural log, and then the innermost function is x to the 7th plus 3x to the 4th minus 2x squared, yada, yada, yada. So when I take the derivative, first thing I'm going to do is take the derivative of the outermost function. The derivative of cosine is negative sine, and then we leave everything inside that function alone. Okay, then times the derivative of the next function. The next innermost function is natural log of x to the 7th plus 3x 4th minus 2x squared. The derivative rule for natural log is the derivative of what was inside the function. So x to the 6th plus 3x to the 4th minus 4x. Sorry. Got distracted by some fur on my pen. Where's the eraser on this thing? Is that an eraser? Is that what that icon means? It is. Sorry, 12x cubed minus 4x. All over what was originally in the function, x to the 7th plus 3x to the 4th minus 2x squared. Oh my God. What a never-ending horror this is turning out to be. Anyway, that is the answer to this problem. The derivative rule for natural log is the chain rule. So by doing the derivative of natural log, we've done the last chain rule. So this is the answer. That is, it appears to be answer choice C. So that's the answer. I'm about to run out of time, so I'll finish doing the solutions on another video. Hopefully it will go better. This thing's been plugged in for 3 months, but apparently just ran out of batteries, so super. So I'll see you in a second.